Good morning, this is your Stats Sensei, Mr. Spensei, and this is 3B.7, the standard normal problems. It says, draw the graph and calculate the probability. It says X is normally distributed um, variable with a mean of 30 and a standard deviation of 4. So mean is 30 and standard deviation of 4. And by the way, we might as well call this LUMO. It's really not LUMO, but that's what it looks like. Lower upper mean standard deviation. I'm going to tell you this is one of the most important things you'll learn out of this class as far as for college. I'm also going to tell you that I became the stats sensei not because I was smart, but because I took the time to draw pictures. And if you've seen my writing, you can bet that my pictures are ugly, and they are. And so I'm going to show you my sketches as I go that make all the difference in the world, because you've got to get over yourself and you got to draw pictures. If you draw the pictures, you're going to get all the right answers. You're going to be super smart and you'll take my job. You'll become the new stat sensei. So it says, uh, and we even say draw the graph. And by the way, we count off if you don't draw the graph just because we believe in it so much. We have a mean of 30 and a standard deviation of 4. So, I mean, okay, I'm going to start off. I'm going to draw a normal curve. And by the way, you won't be good at it until you practice it. And I don't even draw it well now. It doesn't matter. I know my mean is 30. Awesome. I labeled it and I put a mu there. Or you can put it there. It doesn't matter. And in this case, they want probability X is less than 40. Well, 40, if I have a number line, 40 is above 30, so I don't care. This is 40. But they said less, so I'm looking for this area. So that's my graph. So then what do you do on the calculator? Well, this is why I called it the LUMO. We're going to go second vars, norm CDF. Oh, the first thing it asks for is the lower. Well, where does it go to? Negative infinity. Well, so negative 9 raised to the 99th. And by the way, one thing to caution you real quickly, make sure when you do the negative, you use the little negative button down here. So use that button, negative 9, caution 99. Upper bound, what did we shade up to? Because this is technically going to negative infinity. Upper bound, well, we're shaded all the way up to 40. Then it asked for our mean, which was 30. And then our standard deviation was 4. Oops. Upper was 40. Mean was 30. Standard deviation is 4. We press enter. We're going to stop at 4 decimal places, so 0.9937. There it is. Negative infinity, lower, upper, 40, 30, and 4. Okay? Because remember, this is our lower, this is our upper, this is our mean, this is our standard deviation. That's it. Okay, we have the same problem. 30 standard deviation 4. Okay, I'm going to draw another normal curve. There's another normal. Maybe it doesn't look normal, but it's supposed to be. My mean is 30. And we want the probability that X is greater than 21. Well, I know on a number line, 21 is below 30, so 21 is here, but it says greater, so I'm shading up. Well, where am I shading up to? I'm shading up to positive infinity. Once again, we want our LUMO, lower, upper, mean, and standard deviation. Well, my lower part of my shading is 21. My upper part of my shading is infinity. My mean is 30, and my standard deviation was 4. It didn't change because we have the same. So that's what we're going to plug into the calculator. So we're going to go second vars, norm CDF. Lower bound, oh, lower part of the shading, 20. Upper part of our shading, we shaded to infinity, so 9 caret 99, mean of 30, standard deviation of 4, and we get 0.9877, 4 decimal places. And this is your work, norm CDF. Boom, done. Oh no, we have something tricky. We want it between 30 and 35. Once again, Crazy Stats Guide, draw a picture. And by the way, I'm just telling you, I became the stats sensei and so good at stats when all my colleagues weren't, who were smarter than I was, because they wouldn't draw pictures. I draw pictures, I get them right. I became stats sensei. You can be me too, and only better because you're smarter. Just draw the pictures. So this is our mean, okay? And remember, this is the LUMO. Lower upper mean standard deviation. Well, what's the lower part? Oh, the lower thing is 30. What's the upper? 35. So I know I'm starting here at my mean. I'm shading up to 35. And I just know 35 is above it. Then it asks for my mean. It's like, I already wrote it. You write it again. And my standard deviation is still the same 4 that we had earlier up there. So that's what we're going to plug into the calculator. We're going to do a norm CDF, second vars, norm CDF, lower bound 30, upper bound 35, mean 30, standard deviation 4, 4 decimal places, and we get 0.3943. There it is. That simple. Okay, number 2. A radar unit is used to measure the speed of cars on a motorway. The speeds are normally distributed with a mean of 90 and a standard deviation of 10. Now, hey, that's my important information. I need to write that down. So I have a mean equal to 90 and a standard deviation equal to 10. What's the probability it's driving more than 100? So we want the probability that x is greater than 100, but let's go back to our normal curve. This is the most important thing we can possibly do. We can draw our picture. What's our mean? Oh, they told us it was 90. That's right here. And we already know our standard deviation, but we want to know the probability that's greater than 100. Well, 100 is above 90. Well, that's above 90. And so I'm shading up here. What am I shading up to? Infinity. Now we know the calculator is going to ask for my LUMO. So my LUMO is my lower bound, the lower part of my shading is 100. My upper part is positive infinity. My mean was 90, and my standard deviation was 10. So with that said, I got to grab another calculator. Mine was running out of battery. Someone didn't charge it, namely me. Waiting, waiting, waiting. All right. So we're going to go second vars, norm CDF, lower bound. Oh, the lower part of my shading was 100. The upper part of my shading was infinity. So 9 raised to the 99th. Our mean was 90, and our standard deviation was 10. And we get 0.1586. Okay, moving on to number 3. We're flying, guys. It's incredible. Y'all are so smart. For a certain type of computers, the length of time between charges of the battery is normally distributed. Okay, they told me it's normal. As soon as they tell me it's normal, I'm sketching my normal curve. Whee, there's my normal curve. Oh, that didn't look very normal, but it's going to have to be normal enough with a mean of 50. All right, so 50 is my middle value. I wrote it down, and a standard deviation of 15. So standard deviation is 15. John owns one of these computers and wants to know the probabilities between 50 and 70. Okay, so my lower bound is 50, my upper bound is 70. The calculator is going to ask me for my LUMO, which is lower, upper, mean, standard deviation. And my lower bound, the lower part of my shading is 50. The upper part of my shading is 70. My mean is 50. I already wrote 50, doesn't matter. That happens to be my lower part and it happens to be my mean. And then my standard deviation it asks for is 15. So this is a norm CDF again. You should know that by now. Second vars, norm CDF, 50. Then 70 is our upper. Our mean was 50. Our standard deviation is 15. And we have 4 decimal places, 0.4087. Done. Look at this. Flying. Super smart. One of the most important things you can possibly learn from this class is how to do normal. It's going to show up in college and you're going to be the G just because you know how to do it. All right. You will be the stat sensei at your college. The length of similar components produced by a company are approximately normal. Oh gosh. Okay, so we have a normal. Might as well mean drawing that normal curve. Oops, normal. With a mean of 5. I mean, as soon as I see normal, I'm drawing a picture and I'm labeling. There's my mean, and my standard deviation is 0.02. Okay? What's the probability is between 4.98 and 5.02? Wow. That means I have a lower bound that's below 5 and an upper bound that's above 5. I'm looking for this. So my LUMO, lower, upper, mean, standard deviation. This is 4.98. Upper was 5.02. Mean of 5. Standard deviation of 0.02. That looks really sloppy, but I think you know what it's supposed to be. So here we go. Second VARS, norm CDF, lower part of my shading. Oh, that's 4.98. I see it on the picture. Upper part of my shading, 5.02, not 5.2, 5.02. My mean was 5 and my standard deviation was 0.02. And we get 0.6826 because it's plus or minus 1 standard deviation. There we go. All right. What's the probability the length is of the component is between 4.96 and 5.04? Once again, our mean in this case was 5. Our standard deviation was 0.02. Sketching that beautiful normal curve. And we have a mean of 5, a lower bound of 4.96, an upper bound of 5.04. We want to know the probabilities between that. That's my LUMO. So lower 4.96, upper 5. And I'm going to skip writing it. Although you have to, second VAR is normal CDF, lower 4.96, got it from the picture. Upper 5.04, got it from the picture. Mean of 5, got it from the picture. And I wrote down my standard deviation. Now you have to write norm CDF and your calculator commands, but 0.9544. Boom, done. And that should be your work shown. Remember, that drawing is what makes you the new Stat Sensei. Okay, number 5. The length of life of an instrument produced by a machine has a normal distribution with a mean of 12 months and a standard deviation of 2. Okay, find the probability. By the way, they use the word normal. As soon as they use the word normal, boom, there we go. And we know we have a mean equal to 12 and a standard deviation equal to 2. Let's draw our picture because they told us it was normal, which is all I need to know to draw a picture. I know I'm centered at 12. What's the probability it's less than 7? Okay, well, 7 is below 12, and they want less. And remember, it didn't give me anything less. So we want really, if we're writing the probability statement, which it didn't ask us to, we'd say the probability that X is less than or equal to 7. So in this case, on this one, we're going to go, okay, we need our LUMO. Well, where did I shade to? Oh, we shaded a long time. We went to negative infinity, just like Chuck Connors. Then Chuck Norris. Then we shade up to 7. We have a mean of 12 and a standard deviation of 2. So norm CDF, plugging this in. Second VARS, norm CDF. Please remember for negative using that sign. So negative 9 raised to the 99th. Upper bound 7, mean of 12, standard deviation of 2. And we get 0.0062. We have the same problem, but now, so we're centered, same mean, same standard deviation, but we want between 7 and 12 months. So, drawing the picture, we know we're centered at 12. And 7's below 12, and we want it between 7 and 12. So this is what we're looking for. So my LUMO, lower part of my shading is 7. We shaded all the way up to 12. My mean happened to be 12, and my standard deviation is still 2. So second VARS, norm, CDF, 7, 12, 12, 2. 4 decimal places, 4937. Number 6, a large group of students took a test in physics and final grades have a mean of 70 and a standard deviation of 15. We approximate the distribution of these by a normal. Oh, it's normal. Hey, look at this. And we have a mean equal to 70 and a standard deviation of 10. I'm going to write that down because that's important information. So we know we're centered at 70. There's my normal curve. Centered at 70. Higher than an 80. Well, 80 is definitely above 70, so this is 80. And I'm shading up. What am I shading up to? I'm shading up to positive infinity because they didn't give me an upper bound. So my LUMO, my lower upper mean standard deviation, is 80, positive infinity, mean of 70, and standard deviation of 10. Second vars, normal, CDF. Lower part of my shading, 80. Upper part, infinity, 9 raised to the 99th. Mean is 70, standard deviation of 10. And we get 0.1586 because we're truncating. There it is. Another, and the next one, what's the probability they get a grade greater than 60? Well, once again, we're still centered at 70. And I'll remind ourselves of our standard deviation. We're still centered at 70. But we want to know the probability they have a grade greater than or equal to 60. Well, 60 is here, and I'm shading up. What am I shading up to? Well, I'm shading really up to 100, but we don't do that. We go ahead and take it all the way to theoretical infinity. And we're going to go lower, upper, mean, standard deviation. So 60, infinity, mean of 70, standard deviation of 10. Second vars, normal, CDF, 60, 9 raised to the 99th, 70 and 10, and we get 0.8413. What's the probability that someone fails? Because they didn't draw the normal curve. Oh my gosh, why didn't they draw the normal curve? They could have passed. They could have been the stat sensei, but they didn't draw the normal curve and they failed. All right, so here's my mean of 70. And we want a grade 60 or lower. Well, that means we're shading all the way to theoretical infinity. My LUMO, my lower upper mean standard deviation, so this is negative infinity, 60, mean of 70, standard deviation of 10, because it's the same standard deviation we had, because really what we're asking for is the probability that x is less than or equal to 60. Okay. So second vars, normal CDF, negative 9 raised to the 99th. Upper bound, we shaded up to a 60 because they failed. It's so sad. And we end up getting 0.1586. Number 7, the time taken to assemble a car in a certain plant having a normal. Guess what that means? That means I'm going to draw a normal curve. There it is. Distribution of 20 hours and standard deviation. This should say with a mean of 20. It doesn't say that, so we'll have to fix that. But a mean of 20, standard deviation of 2. So here's my mean at 20. What's the probability a car can be assembled to plant in a period of less than 19.5? Well, 19.5 is below 20, and I'm shading, but what am I shading to? Negative infinity. So my LUMO, negative infinity, upper 19.5, mean of 20, standard deviation of 2. Guys, this may seem easy, but I'm telling you, it's one of the most important concepts you will ever learn in this class. So we have negative 9 raised to the 99th. Then we have an upper part of our shading of 19.5, a mean of 20, and a standard deviation of 2. And we get 0.4012. Oops, that didn't go well. There it is. All right, what's the probability is between 20 and 22? Once again, we already know the distribution is normal. They told us that. They told us the mean was 20, and we want it between 20 and 22. So 20 is my lower part, all the way up to 22. And just to remind ourselves, our standard deviation is 2. So my LUMO, lower, upper, mean, standard deviation. My lower part, 20. My upper part, 22. Mean of 20, standard deviation of 2. Lower, 20. Upper, 20. Mean, 20. Oop, lower, I'm sorry. Upper part of my shading, not 20, 22. Mean is 20, standard deviation is 2. Now, I got to tell you guys, I'm being a little bit flippant about being writing it down and my work not being pretty. It's not. My drawings were never pretty, but I did take the time to do them slowly so that I could read them and my professor could read them. So it's really important that you take the time to draw these slowly so that you actually think about what you're doing. So do think about what you're doing. So I get 3.1413 because we truncate after 4 decimal places. Number 8. The annual salaries of employees in a large company are approximately normally distributed. So once again, they tell me it's normal. Our mean is 50, so mean is 50K. With a standard deviation of 20. What percent of people earn less than 40,000? Well, 40 is below 50, so we have 40,000. And we're shading to negative infinity. So we have my LUMO, my lower, my upper, my mean, and my standard deviation. My lower is negative infinity. My upper is 40,000. My mean is 50,000. And my standard deviation is 20,000. Lots of zeros, but that's what we're going to plug in. So second vars, norm CDF, make sure you're writing that down. -9 raised to the 99th. Upper, 40. Mean. There we go. And we get 0.9599. I have a typo. Let me go back. Second vars, norm CDF. I typed something in wrong. I typed in 5,000 and I should have typed in 50,000. There we go. 0.3085. There it is. What percent between 45,000 and 65,000? Once again, here's my mean, 50,000. My lower part, 45,000. My upper part, 65,000. We're looking for this, and don't forget, my standard deviation is 20,000. And by the way, if they had asked us to write the probability statement, we would have, well, let's do our LUMO first. Lower, upper, mean, standard deviation. My lower is 45,000. My upper part of my shading, the upper mark of my shading is 65,000. My mean is 50,000. And my standard deviation is 20,000. Second vars, normal, CDF, 45,000. 65,000. Mean of 50,000. And we end up getting 0.3720. Now, what I was going to say, if they'd asked for the probability statement, we would have said probability that 45,000 is less than or equal to X is less than or equal to 65,000. That's my probability statement. And you can see, oh, it's just between 45 and 65. Yep, no big deal. There's 0.3720. Okay, last problem. What percent of people earn more than 70,000? Once again, we're still working with that same normal. We know our mean is 50,000. And we want to know the probability to make 70,000, but they can make all the way up to infinity. And just remind ourselves, our standard deviation is 20,000. So we do our LUMO, lower, upper, mean, standard deviation. My lower bound, 70,000. My upper bound, positive infinity. My mean, 50,000. And my standard deviation was 20,000. Second bars, normal, CDF, 70, 1, 2, 3. Infinity, 9 raised to the 99th. We already have our mean and standard deviation in, and we get 0.1586. All right. Appreciate you watching, and I look forward to seeing you on the next one. Hope this helped. Thank you.